so we had our first autograder homework due on Friday, and as expected, it's been a little bit of a disaster. This is a big class with 100 plus students in it, many of whom aren't in CS, and so not a big deal. As long as you pushed up to GitHub, even if you didn't submit properly in Canvas, we can still give you the grade that you earned. But I just want to really quickly go over and show you, this is the repo that I have set up for me for this class. And what you need to submit is, if you click on this link over here, it'll take you to an autograder run. So we create a release on every autograder run and populate it. And so what I want you to submit is this URL. That's the URL that I want you to submit. I know some people just didn't submit anything. Some people just submitted just their repo URL, but I really want to get that, and that establishes what date and time you submitted so we can make sure you guys get full credit. So I sent an email to everyone who had not submitted. So check your Canvas messages. Even if you feel like you submitted, just to, like, that'll tell, because Canvas has a function where I can send a message to everyone who doesn't have a recorded submission for it. And so that message will let you know whether or not it's submitted or not. What else? I think that's it for now logistically. Today, we're going to talk about window functions, and I'm going to admit something to you, which is I have never used window functions professionally, and I only found out about window functions like about 3 months ago, but they're very cool. So I'm going to try to show you what they are and how you might use them in your own career. And this is something that I would consider pretty advanced SQL. So I worked professionally for a bunch of years doing SQL work along with Java and so forth. And I never once came across these things. But again, I think they're pretty cool. So we're gonna talk about them. So we've talked about aggregation functions, and aggregation in SQL is done with the group by. And so this is a query that takes all the tracks, selects all of them because there's no where clause, and then collapses them into groups. It collapses them into groups by album ID. So what that means is every track that has the same album ID is going to end up in the same result. It's going to end up in the same result. And we use an aggregate function count in order to count the number of tracks that fall into a given group. And so in this case, all the tracks that are on a given album would be in the same group. And so we would end up with a count of tracks by album. And so if I come over to IntelliJ and I execute this, sure enough, I'm going to get some results with all, for each album, however many tracks there are. Now, if I wanted to get the album name, what would I do? If I wanted to get the album name in this result, what would I do? I think it's album title, right? Album title, I'm pretty sure. I can't say title, can I? Why not? What's that? Oh yeah, turn off the lights, absolutely, sorry, my bad. You guys can't see anything. Turn off all the lights. I'm a creature of the night. I would rather than all this. What about these guys? Can you turn off the can lighting? How's that? You guys, God, that still sucks. Can you guys reach some of those things and pull them down? Yeah, be brave. You got it. Yeah, it's all good. Let's go. We good? How many computer scientists does it take? Okay, okay. So now you can see, well, they figure it out. It's good, it's all good. You can see we want to get the title in this result. How do we do that? Yeah.
We use a join.
We need to join out to that table, right? So we're going to select from tracks and we're going to say join albums. I'm going to just let it do its thing. And we'll say, instead of album ID, and you see when I did that, it's saying, oh, this is ambiguous now. So let's say album.album ID, or albums, excuse me. Sorry, it's aliasing it right here. These are going to be the same because we've established equality in the join clause. Fine, right? But we don't want the album ID. We want the album title. So now if I run this query, whoops, by album.album ID, and I do have to include it here as well. It's going to complain. So now we got a title, so it's not just an album ID. Okay, so you see how we did that? We joined out. It's just taking that table, correlate it with the other table by album ID, and now we can get the results that we want. So this is aggregation, and this is a pretty advanced SQL skill. Like a lot of people go through life without ever using aggregation who work with databases, just using good old insert, select, update, and delete statements, okay? But this is very useful for things like reporting and so forth, okay? Cool. So today we're going to talk about something that's related but different. And again, this is something that I have not used professionally, but I saw it and was like, whoa, what's that? And did some research on it. And so I want to just show you this idea. So the concept is what are known as window functions. And so unlike aggregate functions are all about taking multiple rows and collapsing them down to one row, right? When we do aggregation, we're taking multiple rows in a result and then collapsing them down to one row. What window functions are kind of the reverse of that. We're not going to collapse anything down, but we're going to allow you to generate statistics based on the values of surrounding rows. Based on the values of surrounding rows, okay? So without collapsing things down into a single row, we're still going to allow you to do something like aggregate computations, okay? The reason they're called window functions is because the computation of values is done with respect to a window around the current row. So maybe like all the stuff before the current row, all the stuff after the current row, all the stuff within 10 or whatever, okay? And what you can do is you can apply aggregate functions like you normally would in a situation where we're doing an aggregate query with a group by, but you can do it without actually aggregating. And it turns out this is part of the SQL standard. I was a little bit shocked to see this, but this was added to the SQL standard way back in 2003. So it goes to show how advanced this technique is, that since it's been in SQL since 2003. I did some pretty hard SQL in my career, between 2003 and now, and it never came up on my radar, including with some of the DB. I worked with people who were they weren't Java programmers, they were only focused on the database, and they never brought this idea up. So I think this can be considered pretty advanced SQL. And my understanding from reading on the internet anyways, is that like so many other things, it's inconsistently implemented across databases. And so once again, I'm going to have to say, if you want to use windowing functions in a particular database, you're going to need to look into the documentation for that database. So I'm going to show you windowing functions on SQLite, but if, as is more likely the case, you're working with Postgres or MySQL or SQL Server or something like that, the syntax may be different. So read the docs. Basically, the syntax for windowing functions is the over clause. Okay, is the over clause. What it does is it allows you to define a group, an aggregate function like sum. Sum is an example of an aggregate function, right? Count, sum, average, things like those are aggregate functions. So typically they would only be used if there was a group by in a SQL statement. But by using the over clause, you can use them in an unaggregated context. So here's an example. of exactly that, where we're selecting customer ID, invoice date from invoices. So we're selecting everything from invoices, and we're summing the total. We're summing the total. But we're doing that with an over clause. And the over clause is going to define a window. It's going to define a window over which this sum is going to apply. And let me run this really quickly and just show you what this looks like. Okay, so we've got all of our standard stuff on invoices, like customer ID, invoice date, and total. And then over here on the right-hand side, what does it look like we have? What's that? What's it a sum of? It's a running total, right? You see that? So here we have 198, because there's only one, it's 198. Here we have 5.9, use integers for money, guys. Don't use decimal. If you took 366 with me, remember the floating point lecture when I was like, never use floating point for, for financial stuff? This is why, because you get stuff like this. So 1.98 plus 3.96 is roughly 5.93, not whatever, right? That's as close as unfortunately, a floating point can represent that value, okay? And then 3.96 plus 5.94 is roughly 11.88. Is that plausible? Or no, 5.93 plus 5.94 is 11.88, because it's a running total. So you see how it's a running total? That's what's going on here. And each row has all the data for that row. So this invoice was for $8.91. But at that point, the running total of all invoices was $20.79. All invoices up to and including that invoice, okay? And so you can see how that might be useful in a business context, right? Like I want to know what my total profits were for the year. I want to see all the sales by date, and then, you know, when did I hit like a certain payout or something like that. Like very useful functionality. It's surprising to me that this never came up in my career. If I were doing this, if you, before 3 months ago, if you'd asked me how to do this, I would have just written Java code to do this. I would have just summed it up myself, okay? You can also add a filter, and the filter will eliminate items from the window. So if you have some elements that are in a window and you want to eliminate them, you can use the filter clause before over. And so this eliminates all of the invoices where the customer ID is not null. Or excuse me, it eliminates all invoices where the customer ID is null. It's a positive statement. It's a positive statement, okay? So you can filter and say, I only want invoices that have some characteristic. Maybe they're in Canada or whatever it is, right? So we can apply a filter to that window, okay? And so the over keyword is really the key to this. And this is what defines what's known as a frame or a window. It defines the rows that are going to be aggregated in the aggregate function for the single row. And that's, again, really the big distinction between aggregate functions, or between traditional aggregation, as I understood it until 3 months ago, and window functions, okay? So this is going to define some window over which to apply the aggregate function, even though it's a single row. And in SQLite, there's 3 different frame types or window types. The first one is type range, and what that is basically an ordered set of rows relative to the current row, and you define that with an order by. Okay, so when you're thinking about windowing functions, you have to think about the current row and then the window relative to it. When we use order by, we just think like, what are we grouping into? Which for me is pretty intuitive because I've been doing it for a while. You're trying to group things into buckets, like fine. whatever, okay? But with with window functions, what we're thinking about is, what do I want to be part of this computation relative to the current row? And what's the current row? Well, it's whatever row is being processed by the database at a given point, okay? And so here, here what we're saying is, we're going to select these values, and I want you to sum up the totals, and I want you to order by invoice ID as the running total. And so what that's going to do is it's going to order your invoices by invoice ID, and then take all of the invoices from start to the current row. That's the window. If we did descending, if we went the other way, then it would be from the current row to the last invoice. And so you get sort of a reverse, what would we call that? Reverse aggregate sales, like a burn down of sales, I guess is the way to think about it. Okay, it would be the opposite. But because we're doing order by, default is ascending, the default frame setup is going to be from the start to the current row. Okay. So the second type is groups, and groups are a way to find all the rows that have the same value for a given thing, for a given property. So if you wanted to group by albums, for example, if you wanted to compare a row to everything on the same album, then you might use group to do that. That's different than a full window where you're going from the start to the current row, okay? It's a little confusing, but this is like the basic example. Again, if we were to type this out explicitly, what we would say is range between unbounded preceding and the current row, exclude no others. Okay, that's what you would say explicitly if you were defining this window. Okay, this is the default definition of the window. So what does that mean? Okay, this is how we would have to type it out if we weren't using the default. So thank goodness it's the default. So what does that mean? It means we're going to define a range. Let's go back. We're going to define a range of values between unbounded preceding. So that means go all the way back to the very start. This window starts at the very start of the results. And current row, so it goes up to the current row, exclude no others. That means don't exclude the current row or anything else. Okay? And so this defines that range of from the first result to the current row, inclusive, ordered by the invoice ID. Okay? See how that's defining a window? You see why it's called a window? Okay. So in English, the way to read something like this, the shorthand version of it is keep a running sum of the total column. Keep a running sum of the total column, ordering all invoices by invoice ID from the first ID until the current ID, and emit that as part of the result for this row. That's a pretty sophisticated sentence, even in plain English, right? Makes some sense, but it's pretty sophisticated. And again, this is pretty advanced SQL. But pretty neat that you can do it in SQL, all right? Once you see it, it's not so bad and very useful for reporting, okay? So we could reverse that by using, unfortunately, there's no default syntax for this. We have to be explicit in this case. If we want to reverse that and do a burn down instead, a revenue burn down, we would say order by invoice ID, range between current row and unbounded following. So go from the current row to the end of the result set when we compute this sum. All right? And you can also do numeric bounds. Like if you only want to do like the next 10 rows or something like that, you can set hard numeric bounds like that as well. using window functions. Is that going to be useful? I don't know. I couldn't come up with an example where that was useful, but presumably, given that it's in there. So let's run this real quick and see what this does. And so you can see there's a total of $2,328.68 worth of invoices in the system. And you can see how that value goes down. This value goes down with each row now, because we're summing not from the first invoice to the current row, but instead we're summing from the current row to the end of the invoices. See how this is a revenue burn down? As we scroll down here, it's going to get lower and lower and lower until we finally get to the final sale. See that? So we've reversed it by defining a different window with this crazy syntax. I don't know what to tell you guys. It's just crazy, but that's what the spec says. So, okay. So we've defined a window from the current row, unbounded following, which means all the rows that follow it unbounded, so all the way to the end. Okay. All right. We can also use between to define a range if we want. So between the current row and unbounded following, if we don't want to include the ends in our window, current row means the current row, obviously. Unbounded following means all records that follow it. And the grammar for this, which I looked up in the SQLite documentation, is pretty crazy. Okay? So you can define a range or rows or groups. We'll talk about groups in a second. And then between unbounded preceding, between some number preceding, like 10 preceding or 50 preceding or whatever, between current row and, so you can basically define any window you want. Numerically, unbounded, following, preceding. You can define any kind of window you want. Unbounded preceding and unbounded following would be essentially an aggregate query, I think, if I'm doing my math right. But you can define these things in a bunch of different ways. You can then exclude the current row, exclude tie, like there's a bunch of different things you can exclude as well. So it's a pretty crazy syntax, but most of these things make sense if you look at them in isolation. If you think about, how am I going to define a window of things to be aggregated for every row in my result set? Okay. All right. What if we wanted the cumulative revenue per customer? What if we wanted a running total of revenue per customer? Turns out the window functions also support partitioning. And this is really crazy, okay? So imagine you wanted to get every result in a group by. You wanted a row for every result in that group by, plus you wanted the aggregate information about that row. Okay? And an example, a good example of that is, what if I wanted to get all invoices with a running total by customer ID instead of just a running total for all invoices? Okay? In order to achieve that, you can use the partition clause, where you say, okay, we're going to compute a roll-up. We're going to compute an aggregate function for every row, right? And we're going to keep track of things. We're going to do our order by, so we're going to be from the first row to the current row, okay? But I want that aggregate function to be done only on things that match some criteria. So I want that aggregate value to be done only on invoices that are for the same customer. Okay? So in order to achieve that, you can use inside of an over clause a partition by. It's kind of like a group by, kind of, but they call it partition by. I would have called it group by. I don't know. Maybe not. But it's sort of like group by, but for windowing functions instead of aggregate functions. So let's run this, take a look at what happens. Oops, I didn't copy it. So now, if I come up, what you'll notice is that customer one, as we go through these invoices, we get aggregate information, but then as soon as we flip to customer two, the aggregation starts over. Do you see that? So instead of a global running total of invoice value of total sales over all invoices, what I'm getting instead is a running total by customer ID because I've partitioned by the customer ID. So you see that? Just this little change right here, and now we get this very different behavior. Very useful, I think. I mean, imagine if you wanted to partition by state to see running totals in a given state or county or city or whatever it is. Useful, very useful piece of functionality. Again, I'm somewhat shocked that I never came across this until 3 months ago when I was going through the SQLite tutorial and I was like, what's a window function? So pretty cool, all right? And there are actually window functions that are baked in and that are there to work with, they're windowing functions that are baked in to be used with the windowing syntax. So for example, row number. Row number will give you the row number within a particular window. What row number is it within a particular window? And so if we select all tracks, if we select all tracks, I'm gonna rejigger this just a little bit. So what is this? This is just all tracks, right? Name, track ID, and album ID. That's it. If I add a window function where I partition by album ID, so over partition by album ID, what's that going to do? That's going to partition all the rows by their album ID. It's going to split them into groups by their album ID. And then I can invoke the row number function and get what row number is this track within all the tracks that have the same album ID. So let me run this. Oops. And what do we have over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. Wait, why 1? Because we got a new album ID. So do you see how the row number is partitioned by the album ID? If I just had order by track ID, that's perfectly valid, but I'm just going to get all the tracks in the same group. So row number is just going to go, it's going to basically track exactly with track ID, right? But by partitioning by album ID, I'm saying, okay, we're going to compute a window function. I want an aggregate result for every row that comes out of this. We're not grouping tracks by album ID. We're keeping track of something by album ID. We're keeping track of an aggregate piece of aggregate information by album ID. You see the difference between those two things. That's the difference between a window function and a group by aggregate. Okay? So let me run this again, and you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because they're all on album 1. Then we start over on album 2. Row position 1 within that partition. Album 3, 1, 2, 3. Those are the positions within that partition. See that? Does that make sense? Again, pretty advanced SQL. If this is a little confusing or whatever, like, don't freak out. This was all new for me too, and it took me a while to get my head around it. But useful functionality, because now, like, we could actually print this out and have, like, a list of tracks and what position they are on a given album, right? That's a useful piece of information that previously we didn't really have a good way to do that. So pretty cool. All right. Now let's rank the tracks by their runtime. Okay. This is another, whoops. This is another aggregate function that works with Windows. So what are we doing here? What am I saying here? Select name, track ID, album ID, and milliseconds from tracks. And then I want to rank over ordering by milliseconds. So that'll be from lowest to highest by default, ascending by default. So we're going to get the shortest tracks first, the longest tracks last. And this aggregate window function is going to generate what's the rank of that track. So the shortest track is 1 second, 1,071 milliseconds. I didn't know that until right now. I'm sure I've seen the results of this query before. The second shortest track is 4,884 milliseconds. And over here, note that we have a runtime rank. So we can know exactly what, for example, this track is. Track 84, rank 84, and it's 115 seconds, a little under 2 minutes. Okay? So you can select a rank. You can see what the ranking is of these tracks within this result. Okay? Kind of interesting, more interesting. We can partition by album ID. If we take this same thing and partition by album ID, what are we going to get? We're going to get the ranking of the runtime per album. So rather than being compared to all tracks, it will be compared only to tracks that are also on the same album. So if I run this query, we scroll up, you can see 1 through 10 for the first album, 1 for the second album, there's only 1 on it. The third album had 3 on it, and you can see these are the 3 tracks. Let's narrow these down a little bit so we can see what's going on here. So 1, 2, 3. You can see these are ordered by their runtime, but they're ranked within tracks that have the same album ID. So that's what that partition is doing. It's allowing you to compute for each row an aggregate piece of information. Right? This is information that requires the information of other rows in order to compute. By partitioning, we're saying only compare this row to other rows within the same partition. Or more concretely in this case, only compare this track to other tracks on the same album, have the same album ID. So it's allowing you to do aggregate computations but it's not grouping things. It's not grouping things. Rank window. So let's rank. Oh yeah. So when we do ranks like this, one thing to note, and this is kind of interesting. Let's go back to here. Just don't partition it. And I've got to scroll down a little bit. I think it's right there. Okay. What do you guys notice about the ranking, like right here? There's a tie. So how do you rank ties? There's no 88, right? Because there's two 87s. And that's fine, but sometimes people don't like that. Sometimes instead what you want is something called dense ranking. If we run that same query using the dense rank function instead of the rank function, what you'll see is that we have two 87s, but instead of going to 89, we go to 88. And so that's a dense ranking because there's no holes in the rankings. And so that would be how, for example, like if you ever watched golf, the leaderboard is a dense ranking. You have your top two. If they're tied, the next person is number 2. They're not number 3. Okay? So that's what's known as a dense ranking. Okay? There's some other windowing functions that are useful. So cumulative distribution, if you want to calculate a cumulative distribution. End tiling, which I've got to be honest, I saw it and was like, that seems really confusing to me. But what you can do with it is basically bucket rows into n different groupings arbitrarily. And I could see that being useful for example, randomly assigning students to groups. Something like that. I need to play around with it, but that's the impression that I got from it. Lag is something that you can do where you can basically compare, you give it an expression and an offset, and you can compare the current row with another row lagged by some amount. So for example, if you wanted to find out for every sale, for every invoice, what was the delta in time between that invoice and the previous invoice, you could use the lag function and subtract the invoice date of one previous invoice from the current invoice and get a lag computation for how long it was between sales. I could see that being useful, for example, to find out dead zones in your sales data. Like how come we didn't sell anything for 3 weeks, something like that. Okay. This is very advanced SQL. This is pretty complicated stuff. Again, I had not seen this until 3 months ago, and only by happenstance I was going through the SQLite tutorial and saw it. But it looks super useful to me. Like if you need to do aggregate, if you need to include aggregate data in a report, this seems like a super useful piece of functionality. So am I going to ask you guys to write any window function SQL? No, I'm not. I don't think I am. I'll look at the homework, but I'm pretty sure I'm not. Do I expect you guys to use it like right out of bed in your careers? No. But having it in your back pocket might be useful, and it might make you a hero at a company at some point when you can do something using the database instead of writing a bunch of Java, which is the way I would have handled most of these problems previous to me finding out about this functionality. Okay? All right. If you want to be a SQL ninja, there's always like 2 or 3 people that really want to like be SQL gurus. This is the sort of thing that even the SQL gurus I knew never mentioned this, so they must have been keeping it to themselves. We've discovered the secret of the SQL Ninja Temple or whatever. Okay, so pretty cool functionality, and that's window functions. All right. If you haven't turned in your homework, don't freak out. Just get me that URL and I'll make sure that you get the correct score. The next time I won't be so lenient, so make sure you submit the proper URL for homework too. I'll see you guys on